Hi everyone, this is Mrs. McCullough, and we are going to take a look at lesson 3.01. So if you have your notebook, be sure that you write down this lesson in your notebook, as well as the title, so that when you need it, you can come back to this lesson in your notes and see how we did these types of questions. So this will be on expanding and simplifying expressions, and it's lesson 3.01. So when we're watching this video, these are our lesson objectives. In other words, it's what are we going to learn? And by the time you're done, you should be able to combine like terms, which remember, I'm going to write this really quickly, but a like term would be anything with the same variable and the same power. So if I gave you these two terms right here, 2x and 3x, those are in fact like terms because they both have an x, and they both have an x that has a power of 1. Now, if I put this here, 5x squared, these would not be like terms because this has a power of 2. So you should be able to combine like terms. You should be able to factor and expand linear expressions using two properties, the distributive property, and then we'll talk about factoring as well. And then lastly, you want to be able to add, subtract, factor, and expand, which is like using the distributive property, linear expressions using the properties of operations. So this is all kind of confusing to you, I'm sure, but by the time we're done, these are all of the different objectives that we should be able to meet. Let's start with a few notes and then we're going to try some practice questions. So my first question for you is, what is the difference between the distributive property and factoring? So I want you to think about that. What do you remember about the distributive property? And then what do you remember about factoring? And you may want to draw this in your notes so you have some information that you can use later on. And if you look here, I actually gave you the same picture in both of these sections. Now in this first side over here, we're going to take a look at the distributive property. And notice that in distributive property, you have this word called distribute. It's almost the whole word, actually. It's very similar to distribute or distributive property. And so imagine being somewhere and if a teacher asks you, hey, distribute these papers to the class, what is she meaning by that? That means, if you hear the word distribute, that means to share, to give out. So distributive property means something similar. It means to share. So when you look at this example that's listed here, there's usually a number or a variable outside the parentheses that you're sharing with everything inside the parentheses. So you can see here that it's shared with the B and then it's shared with the C. And when you're sharing that, you're usually multiplying. You're actually always multiplying. So whenever you use the distributive property, you should be multiplying. So make sure you put that in your notes. And I'm going to give you an example because these are a bunch of letters that might be a little confusing. So I'm going to give you an example and let's take a look at that. So EX means example. I've got, let's say 3, and then inside the parentheses I have an X plus 2. And if it says, hey, use the distributive property to simplify this, the first thing I want to do is, like my picture shows me, I take whatever's outside of my parentheses and I distribute it or share it with everything inside my parentheses. And I always, always, always do that by multiplying. You always multiply. So let's do that and see what we get. So we get 3 times x, which is 3x. And then you have 3 times 2, which is 6. Now that's a positive 6, so I'm going to put a plus sign in front. So my answer here is 3x plus 6. So if it asks me to distribute, then all I would do is multiply that number with everything inside the parentheses. Now, how is that different than factoring? How are they related? How are they different? Now factoring, because I use the same picture here, it's actually very similar. It's just the opposite of what you would do for distributive property. So for factoring, you would be given a statement or an expression, and it's going to say, hey, work backwards and take out what they have in common. So you want to find what's in common, take it out. And you've actually seen this before. It's called the GCF, the greatest common factor. And so the GCF is usually the very first thing that you see here before you see the parentheses. In our example, well, actually, let me give you an example of the factoring one so we can see what we would do there. So here's my example for if I were factoring, if this said to factor. Or it might say come up with another expression that's equivalent, that's the same thing. Let's say I had factor 3x plus 6. Okay, now this is what we got as our answer last time, but now I'm giving you this, I'm giving you the answer and I'm saying, hey, how would I factor that? So the very first thing that I want to do is I want to look at both of these terms and I want to say, okay, what do both of these have in common? And when I look, I have a 3x and I have a 6. Well, right away, we know they don't have an x in common because just that first one does. So we need to look at the numbers. And you can see that both of them can be divided by 3, right? Both of those numbers are divisible by 3. That's the greatest common factor. So when I write out my answer, that 3, that GCF, should be outside the parentheses. And then I'm going to look at each term and see what's left. So if I look at this very first one, I do 3x divided by 3. And 3 divided by 3 is just 1. And so that really leaves me with a 1x, or just x. When I look at my next term, I have 6 divided by 3, which gives me a 2. And that's a positive 2, so I put a plus sign here. And now I'm done. So once you've taken out your GCF, that's called factoring here. It's a different way to write it. It's kind of the opposite of distributive property. You would have your answer. And notice how that's what I started with here on my distributive property. And my answer is what I got, what I started with when I was factoring. So they're just opposites of each other. Alrighty, let's switch gears a little bit and kind of talk about the distributive property, but also about combining like terms. So we're looking at that objective that says, what do we do when we have an expression and we can write it all out? So this question says to find the perimeter of the triangle. And perimeter we know means to add. So it says, hey, take this shape and add up all the sides. Now, when you look at the sides, you see an x, you see a 3x. Those are fine. But then we see here this parentheses, which is what we dealt with earlier in the video. So my first step, if I were you, like if I were to write out steps, my very first step would be to actually figure out what that answer, that side of the triangle would be without parentheses. So I have 1/2 x plus 14. And I'm going to actually just solve this to figure out what that side is. So what's 1/2 times x? That would be 1/2 x. And then 1/2 times 14. So if you need to write that out, what's 1/2 times 14? What's that going to give us? Well, half of 14 is 7. And it's a positive 7 because it's plus. And if you had trouble with that, you could always make 14 a fraction by putting it over 1. Multiplying across, because I kind of jumped quickly here. 1 times 14 is 14. 2 times 1 is 2. And then 14 divided by 2 is just 7. So that's where we got this side. All right, so I'm going to actually put this side over here so I can see what I have. Okay, so now I have all my side lengths. And I know that when I'm looking for perimeter says take all your side lengths and add them. So I need to add all my side lengths. And so what does that give me? Well, it gives me an x, gives me a 3x, and then it gives me a 1/2 x, plus 1/2 x plus 7. So remember, when I'm combining like terms here, when I'm adding them, I can only add like terms, which means they have the same variable and the same power. Another point I want to add here is there's no number right here in front of the x, so that's a hidden 1. That's like a 1x. So let me go ahead and box all of my like terms, which would be 1x, 3x, and then 1/2 x. Look how I'm taking the plus signs with it. That lets me know they're positive. And when I do that, I get 1 plus 3, which is 4, and then 4 plus 1/2, which is 4.5 or 4.5. And then I just attach my x. I don't do anything with the x, I just attach it. And then I bring down my plus 7. Now, this is actually your parameter. You cannot go farther than this. This is your answer right here. And that is because they're not like terms. One of them has an x and one of them does not. So that would be as far as you can actually go on this problem. Okay, let's try one of these. This one says, write an expression that is equivalent. Remember, equivalent means equal. Equivalent or equal to 2/5 times 2y minus 2. Okay, so the very first thing that I should notice when I see this problem is that I have a parentheses and I have a number outside already. So that should tell me right away that, hey, you have to use the distributive property. So we have to use the distributive property. And remember, that should tell us anytime we see a number outside the parentheses like this, that should tell us right away that we're going to use the distributive property and we're also going to multiply. So that's what I should be thinking right now while I work through this. All right, and remember, distributive property says take whatever's outside the parentheses and multiply it to everything inside. So this one's a fraction, so it can get a little weird. So I'm going to write it out. So it's 2/5 times 2y. And if I want to make that a fraction, I just put it over 1. So now that that's a fraction, I can just multiply straight across. And that would be like 2 times 2y, which is just 4. And then attach your y at the end. 5 times 1 is 5. So that first answer is just 4/5 y. That's what 2/5 times 2y is. Now I'm going to do the next one. And my next one is 2/5 times -2. Right here, this minus sign. It's like a negative. So I'm going to write that out. I have 2/5 times -2. Well, if I want to make that a fraction, I just put that over 1. Just multiply across. So 2 times -2 is -4. And then 5 times 1 is 5. And then I just bring that answer down. So -4/5. And here's my answer. Remember, a minus is the same thing as a negative, so you don't need to write it twice. If you write it twice, it's going to change. Remember, a negative and a negative makes a positive, so don't write it twice, just write it that one time. And then these you cannot combine because one has a y and one does not. So remember, you can't combine them if they're not like terms. Okay, this one's a little tricky, but we're going to go through it and see how it goes. This one is talking about Ella purchasing a game that's on sale. So let's see what happens. So it says, Ella purchased a game that was on sale for 15% off. The sales tax in her county is 6%. Let y represent the original price of the game, and then write an expression that can be used to determine the final cost. All right, so when I'm reading this, and I would also write this one in your notes, I'm going to box everything that I really need to know. It's on sale for 15% off. There's a sales tax, which means I'm going to be adding something, for 6%. And then y is my cost. All right, and another thing to point out here, if you look, is this expression means that there will not be an equal sign. Okay, so let's just take a look at this and see what is this all saying. So y is actually the cost of the game. So if I were to write that out, I would have y as my cost. Now, I want you to think about this. Usually when you buy something, you're paying 100% of whatever the cost is. If it's $10, you're paying $10. If it's $11 if it's on the rack for $11, you're paying $11. That's 100% of whatever it's on the rack for. Now, in this example though, we're getting a discount and it's 15% off. So now we're not really paying 100% of the item, right? We're getting a deal. So if you think about it, if we normally pay 100% for our item, that's our cost, and we're getting a 15% discount, how much are we really paying? Well, what's 100 minus 15? And that's 85%. So if there's 15% off, we're really only paying 85% of the cost, right? So we're paying 85% of the cost. So if I were to write that out as an expression, that would really be 0.85, because we can't put our percentage here. Remember, when we have a percent, we move the decimal over 2 places to the left. So 0.85, and then in math, the word of means to multiply. So I'm going to multiply 0.85 by our cost, which is y. So this is actually how much we would pay. Let me make myself a little note here. How much to pay for item. Now, that's assuming we don't have a sales tax. So now let's think about sales tax. Now, sales tax, let me draw myself a little line here. Sales tax is not subtracting. Sales tax is actually adding. So go back to our cost. If we have our cost for our item, we're going to pay that entire cost. Even if it's the new discounted price, we're paying the whole 100% of that cost, that discounted cost or that normal cost. And we're also going to pay a percentage of it, a sales tax, which is 6%. So if you think about this, we're now paying 106% of whatever our cost is. And this cost might be the original cost, it might be the discounted cost, depending on where you are. Okay, so let me rephrase what I said because this can get confusing. You have to pay for your whole item. So if our item is $10, you're paying the $10 plus 6% of the $10. So another way to think of that is 106% of the item you're paying for. Now, remember, we can't just write 106 over here. We have to actually convert it to a decimal. And we do that by taking our decimal, moving it 2 places to the left. So this is really like 1.06. And then remember, our cost has to be here. So we're going to multiply our tax by our cost of our item. Well, our item is not just y anymore because it's a discount. Our item cost was 0.85. So I would just plug in 0.85y here, and then I would multiply that by my tax, which is 1.06. So just remember, anytime you have tax, you're adding, and then anytime you have discount, you're subtracting from 100.